Hello, Professor. This is Divyang. This is my Lab 7 EE104. So this is going to be our elevator design on the breadboard. In another video, we'll explain the code for it. But for this video, we'll be focusing on the hardware component of this design. So we have 3 input buttons, and each of those input buttons represent a different function in the elevator. So this button right here that represents the LSB, this button right here that represents the MSB. These 2 buttons represent the binary representation of our elevator floor that we want to go to. And this last button represents basically an emergency button, which if pressed, then what will happen is that it will go all the way down, regardless what floor you're in. So that can be pressed at any time. And then we have these 5 output LEDs. So the buttons represent the input, the 5 output LEDs represent the output. These 2 LEDs here, the first 2 red ones on the left side, they represent our binary representation of the floor that we want to go to. And this LED right here, the one that is staying on, this blue LED, that represents our door that remains open at all times. So by default, when you run the code, the blue LED will stay on and it will remain on as long as the program is running. And this LED right here, the white LED, it represents the stop, fast, and slow. And this yellow LED right here, this represents the up and down function in the elevator. So whenever we go up, it's going to remain on, and whenever we go down, it's going to remain on. So we're going to go up and down in this elevator. So these pins right here, so this first button is mapped to pin number 7. The second button right here is mapped to pin 6 on the board. And this last button right here is mapped to pin 5 on the Kriya board. And the Kriya board supplies us the 3.3 volts for positive voltage that enables us to power this circuit. And we have ground connecting to the Kriya board as well. So the Kriya board is supplying our input-output pins as well as supplying our positive voltage and ground. So these resistors right here that are connected to the buttons, they represent the 10K ohm resistors. This is to ensure that we have optimal current flowing in. And for the LEDs, we have 220 ohm resistors. This is also to ensure that we have optimal current flowing in and making sure that if the current going in isn't so high that it just blows out the LED. Because with the diode, you have to ensure that optimal current is going in. Otherwise, in this case, because we have LEDs, if you feed too much current in, then we'll have to replace the LED as it is blown out. So now I will perform the task. So this represents our binary input. So when we go 1, this is going to represent floor 1. So elevator is going up, floor 1, door opens. Now it's going to go back down, and then the door is open. So now we represent floor 2. So this represents floor 2. So going to floor 2, elevator turns on, door opens, and then we're going back down. So the LED turns, so the door closes, we go down, and now the LED has turned on, so that means the door is open. So we're going up and down. Now we go for floor 3. So this is floor 3. So that's floor 1, floor 2, floor 3, door opens. Now we go down, floor 1, floor 2. So now we're all the way back down to our default floor. So with a finite state machine such as this, we always need to have a default state that we want to go back to, and floor 1 is representing our default state. And additionally, for this lab, we also create a melee machine, which is explained over here. So as we can see, this is the melee machine that we have created. So 001 represents the different inputs that we have to put in order to get to the next state. So 001 is our first floor, 011, that's our second floor, 010, that is our third floor. So As you can see, we have 4 floors. That's 4 different states. So state 00 represents the default floor. State 01, that represents floor 1. State 10 represents our second floor. And then state 11 represents the floor 3. We also have XX/00. That represents the emergency button, which goes to default floor 00. So that's why, as you can see, for each state, if we go back to the previous state, we also have the XX listed. So that's the emergency button, because the emergency button can be toggled at any time. And automatically you will go back to the default floor. And this is our button layout that I mentioned earlier. We're going from left to right. So button 7 and 6, that represents our MSB and LSB, and button 1 and 2 represent the MSB and LSB, and button 3 represent the override. Additionally, we also have this. This is a better representation of it, more clear. But as I stated, like for the LEDs, up down represents yellow, and that's assigned to pin 0. Stop, fast, and slow, that represents the white LED, and that is connected to pin 1. And then the door represents pin 2. And then the floor number, which is our binary representation, that's the 2 red LEDs I previously showed on the breadboard. So those were connected to pin 3 and 4. And again, for floor 0, we have the emergency button as well. And thank you. This has been the elevator explanation for the breadboard. And stay tuned for the code explanation in a separate video. Thank you. Have a great day.